Okay, so this is an off-the-cuff video showing how to create a generic throttle quadrant using the AuthentiKit system and AuthentiKit plugin components. You start with the back plate, and I've just made a kind of generic vintage warplane kind of back plate. The height is, what does that give us? Well, you can get a sense of the height there. It's the right sort of height and width. And the origin, important thing, the origin is here, which is the center of rotation for the levers. So that's a good way of doing things. And now one thing is how you do components in Fusion 360. And I've evolved my approach here, but I think now the best thing, I'm going to give you this particular file as a step, as a starting point, just so you can kind of practice doing what I'm doing. So you can start with this back panel. And when you get it, you'll see that there's just one component called quadrant. But what I'm going to do is make another component. I'm going to call that back plate. And let's say that we've got mixture on that, because it's kind of useful and I'm going to drag the back into it. It's kind of useful to keep the plates and the mag hall units together, so you can kind of hide and reveal those on their own. And you can always join them to things, so that's fine. So I'll be able to work on this back plate, and I'm going to I'll put a mixture on the back here, and then I'll work on another plate, which will be the throttle. So let me summarize what I'm going to take you through. So we've talked about the origin and about components. I'm going to be talking about panel thicknesses for 3D printing, strength, and so on. You've got the back and the front, the kind of external panels, which they need a bit of rigidity, but then you'll often need internal panels, either for a friction plate or to mount another mag hole, because typically you've got 3 mag holes. You've got a prop as well. We need to talk about friction, and the AuthentiKit approach to that is to use the felt pads, which stick onto these plates. Then we will be talking about the mag hole and how we mount the mag hole, how we route wires, and then an important area is lever strength. This 3D printed stuff is not as strong as metal, so you tend to need a thicker lever, and that's a challenge, because if you want to try and get the throttle quadrant close to the dimensions of the real thing, you're really kind of pressed for space. Space is really at a premium. So I'm going to tell you the kind of compromises I've come up with, and I follow them. I would suggest maybe you can experiment a bit. I won't in this video do a 3-part quadrant. It's just going to be 2 levers. I'll do another video for that, and I also won't show you any kind of kinked or bent levers. They'll just be straight. And knobs, fire buttons, and so on, bomb release, I won't do that. And I'll do a quick kind of connection to an RJ45. Not the prettiest one, but just kind of something to show you. So let me get started on it. So we've got our back plate, and I've already made this back plate to the thickness I recommend, which is 5 mils. So if you just look at the information there, that's a 5 mil thick plate. So let me line that up to front. So the first thing, we're going to put a mag hole in. Now I said these are at a premium, so we don't mount these flush to the plate, we actually recess it. I found that's perfectly strong enough, so I'm just going to drag that mag hole. So I'll give you that mag hole as a step file. And what I tend to do is just sort of pull it out of the way a bit and rotate it round and get it the right sort of orientation. So that's just been dragged in there. I'm working on this component, by the way, so keep an eye on what component you're working in when you do this. And now I'm going to joint it to this back plate. So I'll do that by hitting the joint, and I find if I tap here, and sometimes I get confused, is that the center? Pretty sure that's the center. You'll be able to test in a second, actually. So there we go. So we've done that. So that's what we're jointing, and we're jointing it to Here we go. We've got the origin. Let me turn off origin here. Yeah, that is the origin and the center of the rotation. And you can just do a quick test. If I just rotate that around, you can see that it's not sort of wobbling off. So we know that we've got that centered in the mag hole. So that needs to be 180. So we'll say OK to that. So that is in. But that's not quite what we want. So I'm going to just do an edit again. I'm going to recess it 3 mil. So you drag it that way into the back plate, and we're going to offset -3. So now it's recessed. Now I've made some tools, some sort of cookie cutter tools to simplify the mounting. If you now expand this, you'll find that the way I've got this component in here, you might need to set it up this way because it's a step file and everything's probably visible. So I would pull in your step file and then prepare your Fusion 360 component like this, which is where the body for the mag hole is visible, the lever is visible, but there's a thing called base blanks. Now, if I now do a combine of that back plate with this base blank, and make that a cut operation. Okay, I don't need the base blank anymore, remove that. If I'm going to hide the mag hole, you can see that we've now made a perfect recess for the wires and the screws and everything. So if I hit E to extrude, and I just take those little slots there, drag them to the back, done. Okay, so those are the mounting holes, and I just hit chamfer, and I do 3 chamfers there, 2 mils what we need. So now we've got the fitting for the mag hole in place. Perfect. So we need to make a lever now. So as I said, we're really trying to minimize space here. And you'll see that the lever that you get, which is kind of ready-made and it mates with the mag hole, it's the new one. If I hide the lever, you'll see the mag hole has that sort of crinkle crowny effect. So all of that's built into the lever. So what you need to do is now grow and develop that lever into a useful lever. Now, you can't just work on that lever. It's in a connected component, and you can't just modify it. So I found this as being a kind of neat trick. If you do combine, you combine with the backplate the lever and make it a join. Now, I can't join them because they don't touch. What it does do is it makes a new thing called back one, which is the lever. And now I can hide the lever from the mag hole unit, and I've got that lever, which is a component that I can now work in Fusion. So this will be, I'll call this a mixture. It's not jointed to the mag hole, so I guess I have to deal with the jointing later. But we can now work on it. So let's make a sketch on that. Now the width of this is 14 mil. Now I recommend that you go for, now in the Spitfire I went 18 mil for the mixture and 26 mil for the throttle. Now one thing to explain here, the mixture lever on the Spitfire had a very small handle on it, just a little knob at the top. Now that doesn't give you a lot of room for leverage. You know, there's not a lot of scope for bending and twisting, which is good because, you know, bending and twisting is something that applies some force to the lever, and we've got to build for the strength with that. So because it doesn't have a lot of kind of twisting force on it, we can get away with a sort of minimal strength lever. So the strength comes from 2 parts. One's the width, so that's 14 mil, and I went for 18, so I'm going to make this 18 mil wide. And the other thing is the thickness. Now I'm going to make you can see here this is incredibly thin, and you might think it's too thin. The thickness of the lever here is only 1.48 mil. That's fine, because, you know, if we went any thicker than that to this side above it, we really make a chunky throttle quadrant, and there's no way we'll get it into the design, the authentic design. I am going to make the lever thicker up here, going this way towards the back plate, and the strength is going to come from gripping that lever between the felt pads. And as long as it's gripped between the felt pads and there's a certain width to the lever, then we're going to be safe, and we're not going to be in trouble. This is certainly proven the case with the Spitfire one by the fact that this is only 1.48 mil thick at that point. I am going to make that thicker than 1.48 for my other lever, which is going to have a bigger handle on it. So there's a real kind of twisting force issue, and we just need more strength for that. Right, so I've talked about that. Let me put some color in here because these things are blurring together. So I'll, just for the sake of a bit of color, let's make the lever yellow. Okay, and the backplate can stay as green. So let's make a sketch on here. Sketch, project onto the surface. Let's just project that whole lever, and I'm going to make something from the midpoint up here. I'm not going to be too careful about it. Let's make it 100. That needs to be a construction line. We don't need that. I will make a, well, like the Spitfire one, I'm going to make something that's 18 mil wide. So let's have an 18 mil wide line, which will be at the top of this lever. I'm going to put a point dead center. Now I can drag that point around. I can drop it here. So now we have the top of the lever. I'm going to draw a line down vertically until it touches. What I can do, I'll just make it touch for now, and then I will just hit the vertical constraint. So now I know it's a vertical line. And just for speed, no, I was going to mirror it, but why do that? I'll just do the same here. I'll just drag it so it touches. Let's get this right. So it touches that side of the lever there. I'll put the vertical constraint on. So now we are there. So we've got a lever, and let's finish that sketch. That's probably enough for now. No, it isn't enough. I need to do one more thing. I need to project that little roundy bit. And the reason for that is, let me hide some of the bodies now. The reason for that is that we're going to be rotating this lever, and I'm going to make it thicker at the back, but I've got to make sure I don't bang into that little roundy bit. So I'm going to draw a line here. It's perpendicular to the lever. I'm going to do right click. I'm going to do D for dimension. Start again. D for dimension, right click, pick circle, arc, tangent, and click on that little roundy projected bit up to here, and make that 1 mil. So now I'll finish the sketch. So now, let me put the bodies back. So now I will hit E for extrude, and I'll extrude that lever, and yeah, everything from there. There's the little arrow. I'm going to make it, what did I say? We're going to make it, on the Spitfire I did 11 mil deep. I think, I'm not quite sure why I did that. I think 10 is okay. Actually 11 is good as well. Let's go 11. If you can make 11, it's stronger. So now we've got an 11 mil deep, thicker lever that doesn't touch the back. You can see there's a gap, and it isn't going to bump into the green thing as it rotates. And what's happened here? I haven't got all of it. Let me hide the back. There we go. I missed that bit out. So let me just modify that extrusion and include that bit. There we go. There we go. Oh, there's a little bit of a nick there, isn't there? It's not so pretty, is it? So let's put a little chamfer on that. Is that chamfer? Yeah. Let's do that. In fact, what's probably nicer again would be a, there we go. Let's make a really big, I just put a huge one, it'll almost disappear. Really big curvy thing, whatever they're called. There we go, radius. There's better ways of doing this, but isn't this 7mm? Gets rid of that untidy little nick there. There's better ways of doing that, I'm sure. Right. Also, I think we don't need that to be quite so square. That doesn't look very good. So let me put a little radius on there. Fillets, that's the thing, isn't it? That's just still perfectly strong if we have that there. 4mm looks good. And I think we can get away with a slight fillet here. Probably 1mm maybe. All right, so there's our lever. Okay, the screw. Now we are going to use an M4 6mm screw. So how much distance have we got from the back, the blue bit, to the top? 5mm. So we don't. So if we were to make our 6mm screw flush to the top here, it would go too far and it would push into the magnet. And what you need to do is, mess things up a bit here, is the amount of screw which projects into the mag hole peg, which is basically the top of the threads here, is 3.5mm. I think I've written that, 3.5mm screw length. That's in my notes. So we need to make, so at the moment, the distance I between the blue bit and the top, which is that ring there, is 3.44. So we want to make the, we want it 3.5. So now I had a different way of doing that. What is it again? Sometimes you do things by trial and error. So we're going to chamfer this. Let's chamfer it by 1. Okay, so distance now between there and there, 3.92. Okay, so we need to take 3.42. We've got 3.92, we want 3.5, so it's a 0.42 difference. So let's make it 1.42. Good. So now the distance between the blue bit and that bit, 3.5. That's what we need. And it does mean the screw will protrude a fraction above the top, but we'll get the maximum sort of bite into there. So now we've got the mag hole fitted, and we now need to think about the friction. The felt pad is 1mm thick, and the distance between the back of that throttle and this plate is 2.14. So we need to make bring forward a plate that we fit the felt over that will leave the right amount of gap between that lever and the back plate so that it grips it firmly, it adds friction, and it gives it strength to protect against twisting and against that fairly weak mag hole mounting. So let's do that. So let's make a sketch. I haven't named these sketches, haven't I? And so this here, this was the lever sketch. So right click on that back plate and do create sketch. I'm going to hit P and project the plate itself. And the felt will go right to the top. And let me just, this is just rough and ready in terms of how I will place it. We can't go right to the edge because we're going to have some sides on this thing. Although I won't do sides actually. I'll do something else. It's going to be 50mm deep. So how about I hit L for line? I'll go down here. For the sake of something, I'll probably make it parallel to the sides. I'll go along, that'll be horizontal, and then I'll come up to there. Right, let's get these tidied up now. So I'll hit the parallel, I'll make that parallel to that side. And that can be parallel to that side. And then hit D, and we'll make it there 50mm. So that's where our felt pad will be. And I'll re-edit the sketch later. There's other things I'm going to add, but for now, let's just save it. Let's call it back plate and felt. I'll do for now. So now let's hit E to extrude, and we will bring that plate out. We will set it to go to the object, which will be the face of the lever. But we don't want to go all that way, because we've got a 1mm felt pad that we're going to put between them. But we don't want a full mill, otherwise there would be no friction. So we're going to leave a gap of 0.25. So we're going to allow for 0.75. So we'll have a 0.25 gap. I think I've got that right. No, it's a 0.75 gap. That's what we need. It's a 0.75 gap. And then when we put a 1 mil felt, we'll be pressing in by 0.25. Now that's a thing you may want to experiment with just to get the right kind of friction. Actually, what we could do as well, just to make that, just to get the appearance of that right. 29. There we go, black fabric. Let's just drag that. It's not onto the whole object, just to the face. Let's just do that. Okay. So now we can kind of remember that we've got some sort of fabric there. Okay, so I'm going to quickly finish off this lever. You've got to think of how you're going to print. You're going to print on that side, that way up, and that's going to be fine with a nice lever, a simple lever, just with a little sort of knob on this side. If there was a knob sort of coming out the top, like a round one, you'd probably do that with a kind of an add-on piece. But anyway, nice simple thing. So what I will do is I will just put a sketch on here. S for sketch. Project. Now then, let's do continue. We don't want to capture position. I must have just dragged. There we go. Right, project. There. And let's just put a line here. So we've got, have I joined that up? I'm not sure if I've joined it up. Yeah, I have. And we'll have make that knob sort of, what's that? Yeah, make it 18. Really, I probably ought to kind of rotate that knob and check it's not going to clash. I'll leave you to do that sort of thing. But we'll rotate it after we've made the button. So, okay, that's done. So let's just call that mix knob. And E, pull that out a bit. That'll do, 15. Let's make it kind of a roundy knob sort of thing, but fill it there, fill it there, fill it there, fill it there. That should be able to make it sort of round. Okay, that'll do. 8 looks like a good number for a fairly round thing. 5, how about that? Yep, so we've got a round thing. And let's just round let's fill at the top as well. Let's make that sort of 3. Yeah, that's kind of nice. 4, 3. Okay, so there's a knob. Now 2 more things. Because we're dragging this 3D printed lever against fabric, we're going to wear the fabric away. So we should put a little bit of a fillet. Not a fillet, a chamfer. We could fillet this. Fillets are sort of nicer, they're rounder. You can't fillet to the print bed. I'll just explain that in a second, but we can round that. That's quite good. 1 mil, I think, is good there. So that'll smooth and reduce the abrasion and erosion of the fabric. So that's there, but we can't fillet that side. It just doesn't work because of the angles that you get when you're printing a base layer. You're printing up. We can fillet. We can chamfer. So let's chamfer that. And 0.5 is probably what we want there. I'll just take the sharpness off it. So we're going to have some fabric there. Right, so that is a lever fully working. Yeah, go on, we'll just put in a joint on that joint already. What was that? Oh, let's remember what that joint was. That was the mag hole joint. Let's make another joint. It'll be an as-built joint. I quite like as-built joints, they're easier. We'll have one on the lever and then one on the mag hole. I think we do want another one. I think so, yeah. And it's a revolute. And the snap, any of the roundy things is an indication of the snap. No, that's gone wrong. Let's try something else. As built joint that with that. No, that with the back. Let's try that. No. As built joint with the lever. Ah, the lever and the back are in the same body. They're in the same component. We can't have a joint there. We have to make the lever separate. Actually, I'm not going to bother with that right now. What I can do is I can do an M for a move. I'm going to select the lever. I'm going to select the pivot here. And then I'm just going to do some pivot point set. And then I'm just going to do some little tests as to what happens if I rotate, whether that sort of hits the kind of hit the back out. I've made it too short. So let's just cancel that. And if we go back to the drawing, that's the knob. I want the lever drawing. Edit the lever drawing. Let's make that 110. Yeah, that's safe enough. Okay, you can do a better job than that, but that's where we are for now. So let's move on. We've got one lever in. We need to put in a friction plate. So this side of the lever has got some friction, and we need to be gripping the other side for friction and for strength and to prevent twisting. So a way we can do that then, you've got to think about how you're going to do sides and how you're going to sort of connect up the body pieces of this throttle. But I'm going to do something a bit like I did on the Spitfire. So I'm going to edit the back plate with the felt on it, and I'm going to make some little connecting lugs that we're going to have some screws going in. I'll make a line from up here that will be halfway between the felt and the sidewall. So let me just put it anywhere for now and just connect it anywhere. And then I will use the symmetry to go with it halfway between there, and that's what we want. So that's our wall done. Let's put a line up the middle, just any old line, just so that we've got ourselves a mirror ink axis. And now I'm going to just mirror that line. Actually, let's make it an X. It's a construction line. Select it, hit the mirror, select this mirror line, and now we've got one there. And I'm going to do a C and make a 4mm hole. That's going to be where a screw thread's going to go, and I'm going to hit O for offset and make a 2mm offset. So that's a strong enough tube to hold the screw. And I'm going to have one of these up here. Seems to want to move. I think I've locked it for anything. Sketch point, line, dimension, profile. Let's finish the sketch. And let's edit the sketch again. Right plate, edit sketch. Doesn't want to move. That's 4. That's, if I've locked it to some place accidentally, sketch dimension, profile. There's no constraints showing up. I don't know what I've done. Okay, this is what I tend to do. I'll just delete it. Have another go. Is it moving now? Yeah, it's moving now. Let's coincident it to that line. It should still move. It should still move. So another go. Start again. C. Put it here. 4mm. Should move up and down the line. Okay, it doesn't want to move. Let's just try something else. Let's make it move with a constraint. Okay, so let's put a distance between that point and this point here. Distance, try again, between that point and that point. Often if you do this too quick, it doesn't work right. Let's do it carefully. Tick there and tick there. There we go. Let's make that distance 10. Oh, it's happy to move now. Fine. Let's make it 7. Seems okay. Right, let's have another one. C for offset on that 2. Okay, and is that moving by itself? No, that doesn't want to move. That's fine though. I think what I will do here is to get the distance right, I will make a line here which continues straight across. Make that construction line, and I'll make that tangent to this line. There we go. That fixes it nicely. And so that's going to hold the, it's going to serve two purposes. One, it's going to be support for this friction plate. Secondly, it's going to be part of the strength of the whole body. I'll need another one down here to hold the body. So let's put that sort of, let's have that kind of level here. It should be a horizontal line. It's probably made a right angle tangent. That's fine. So we'll put one here, make that 4, and that again, offset 2. So now we've got another one there. Now let's duplicate everything. So we're going to mirror that and, no, carefully mirror that and that, that and that, that, that. Mirror line, this thing I made here. Okay, so now we've got those posts. Start building. I need to reveal that backplate sketch, and let's hit E for extrude. We'll extrude that and that, and that and that. Bring those out, and we want those to be as far as here, plus 0.75. So 0.75. Yep. So again, we've got 0.75 for the felt. Okay, let's build a friction plate. So that's going to be a new, let's hide that, it's going to be a new surface, a new plane. I'm going to build it on this plane here. Select it. And let's project. Let's project that, that, and that, and that. Let's project this, and this. Body of the back plate and the posts up here. That'll do it. That's all we need there. Okay. Let me just hide the plate so I can see what we've got. Right, so this plate, I'm going to, yes, I think I will. I'll go all the way. I'll make it a straight thing all the way to the end. Okay, so that can be my plate. Right, let's put it back. But now let's hide that again. So let's extrude this plate, and we also want this, 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 this. And we're going to make that 4 mil thick. So that's inner plates 4 mil thick. So if we put the body back, so now we have our lever, and there should be a 0.75 mil gap between the lever and that friction plate. Okay, there we go. That's what would be nice. I think a little bit of filleting here would look pretty. What's the right amount? 4, I'll do. Let's give that some color so it's easy to find. Paint, green. Okay. Good, so we'll have felt on there. So we don't need to bring that out anymore. We'll just put the felt straight onto that plate. It'll be felt straight onto this plate. Right, so we're halfway there in terms of the levers and the body. So we're going to now have to create another plate, which is the front plate, and another lever. So let me make a component here. Let's go up here and let's make a new component. And we'll call this front plate. And let's start. Now there's different ways we can do this. I think what would be a good way would be to make an offset plane from here, which is the back of the friction plate. And I don't know quite how much yet, so I'm just going to make it loads. And then we'll fix it. Okay, so on that plane, we will sketch and project the P for project. Are we sketching yet? I don't think we're sketching yet. Sketch, project. There we go, now we're projecting. So let's project this. Project all of it. Okay. And let's project that line there. Okay, now there's all this stuff here for the mag hole. We don't need all of that. I just put it on its side. I should be able to draw a lot of selections and get rid of them all quickly. So that's all right. Okay, that's good. Keep all this stuff. I think that's, yeah. No, do I want this curve? I don't want that curve. That just gets in the way. And that line, don't want that. That line, yeah. Okay, that's nice. That'll do for now. Okay, so now we have a front plate. And I will extrude that. I need to select that and that. And this. I will pull it this way by 5. Okay. Good. So that's the front plate. Now we're going to have another mag hole. Let's drag that in. We're on the front plate component. So the mag hole will be part of that component, which is what we want. Let's get it roughly the right way. Okay, it's going to be that way. That. That's good. And let's make a joint between here and I think it's that place and there. If I slide it around, yeah, I've got the right center of rotation, that's good. And we're going to indent it 3 mil minus 3, centric as before. We go down to the mag hole and we show the base blank and we do combine backplate, select base blank, and we do cut operation, gone. We don't need the blank anymore. Reveal that. Let's hide the mag hole. Let's hit E for extrude and punch these holes through. Distance to the far side. Done. Hit chamfer. Chamfer these holes. 2 mil. That's what we need. Right. So now we've got a mag hole and a. So this will be our throttle lever. Now we've got 2 big components, front plate, back plate. So I'm going to hide the back plate and let's work on the front plate. Same trick as before, we need a workable body. So that body is the front plate. We now need a workable lever. So we'll do that trick. We select the back plate, we do combine with the tool being this lever, and it's a join, and we say OK. Now we've got a lever we can work on. We can hide the lever that comes with the mag hole. I'm going to give this a color. It's grey color. Now, this lever is going to have a bigger handle, which means it's going to have a twisting force, which means that this thin 1.48 thick piece here is just too thin. We're not going to get away with that. So the thickness that I recommend, so what are we going to do? 1.48, 3.5 is what I suggest. So let's E for extrude and let's take that out 1.48, 1.52, is that right? So that there should be 3. Oh no. Should be 2.02, I think. Yeah, 3.5, so it's thicker. Let's get the screw right. The distance now between the bottom of that mag hole seating is 6.94, which is too much. We only want, we're not going to bite all the way in, so let's put a chamfer. Let's do it by trial and error again. If I make that 1 mil, we want full 3.5 mil traveling from that point to the bottom of the chamfer of the screw to the blue. At the moment, the eye between there and there is distance is 5.94, so it's too much. So what did I say it was? I between there and there, 5.94. So let's adjust that chamfer. Edit that chamfer. 1 mil, and we want it to be, we want the difference between 5.94 and 3.5. So we could say plus 5.94 to 3.5. That should do it. So now I between here and here, 3.5, perfect. We've ended up with a huge kind of scoop and a hollow here. So we'll fix that in a second. We'll fill some of that in as part of what we're going to do. Right, we're going to make a throttle lever. It's going to have a bigger handle. There's going to be more leverage, which is going to be more stress on this object here. So as well as making it thicker, I'm going to make it wider. So peace of mind. So we'll hit S for sketch on that lever. We'll hit project. Let's project all of that. While I'm here, I'm going to fill in a bit of this. So 8 mil is enough to sink the head. Let's make it 8.2 just for peace of mind. Okay, now then, let's make this lever. We will have a line from up the center here. Nice big lever. Let's make that 1, 2, 5. Okay, X and L line. Let's go across here. Any old distance for now. Let's bring it. That's a thick old lever, but let's go for that. Right down to that point on the circle. And then let's make this up here a right angle. Okay, so what distance is that now? That's 10, so it's going to be 20 mil wide. You might not want to do that much, but for this, I will do it. Now let's mirror that, just for speed. Mirror those two lines on the center line. Okay, so now we've got that. Now we need to project again this little bit here. So now that we can draw a line across here, we can hit D, circle tangent between there and there, and we want 1 mil on that. That's enough for now. Okay. Good. Right, let's extrude in 2 parts here. Let's extrude that bit, and that bit. And add those on. Distance to object to this point here. Okay, so everything is now the kind of 3.5 mil as the minimum thickness. But we want more than that. So let's make sure that we're showing the sketch, this new sketch. Let's extrude again, that and that. And we're going to go minus 10 mil. Oh, that was a cut operation. Edit the feature and make that a join operation. Right, now we're going to that's a pretty strong lever. Probably doesn't need to be that strong, but it makes the point. And let's do a little bit of chamfering here. Not chamfering, filleting. Doesn't need to be quite as much here. This is a chunky old lever. Let's put us another fillet in there. Well, it looks like I'm pushing it a bit. I think 1. One's probably safe, so I don't catch it on the end here. Yep. Okay, so that's lever there. And let's put a sketch here. Project. Project. Very good. And a line here. And this is going to be really just rough and ready. 20. I'm just going to do some crazy thing. What am I going to do? Make it up as I go. I will. So I'll extrude. Right. 1 mil. Then I will fillet this and this. And this and this. Build them out. There we go. I'll do 9. Then I will extrude that handle, but I will give it a little bit of a flare. There we go. Say 30. And I'll extrude again without a flare. Yeah, good. It's a bit crazy, but it'll do. 35. Oh, missed it. 40 then. And then I'll make that a big sort of roundy thing. There we go. Oh, and I might just fillet that a bit as well. It's not a lot of scope there, I don't think. Not quite sure why. Yeah, okay. Just happy with that. It's a decent amount. Right, so that's just a crazy made-up sort of handle. But the point is, that needs, that's going to give leverage, isn't it? Which is why we now need a strong handle for it. I think before I finish, I need to remember to fillet these top pieces so that they're 3. Making it up a little bit here. Okay, let's hide the sketches and then chamfer this 2.5. Okay, that's good. So I'm not going to wear away the fabric. Okay, let's hide the lever. Same old thing with the felt. Hopefully we can just project this sketch on the back here. Create sketch. Project. Let's show the back plate. Let's see if we can project some of this. I have to turn it this way around. Yeah, okay. That. Now, I'm getting a little confused. Let's hide that. Just need to get the bit we want. We don't want body 3, which is, we want this, 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 and this. That's what we want. Okay, let's hide the back plate again. That'll do for now. Yep, good. So let's bring that out. Let's put the, show the lever again. Let's extrude that. Take it as far as the lever here with an offset of 0.75. Done that right? Yep. So that's the friction plate, and we can put some felt on there. Felt to the face. Okay, that's that done. Let's put the front and the back together now, try and work out what's going on. Look at the whole object, the whole quadrant. And let's put this, this is a friction plate, that's what it's called. Really spelled, okay. Okay, now let's correct the separation. We want the distance between that and there to be 0.75, and it's 29.84. So let me go back to the front plate and let's correct that separation to plus 29.8. Take 29.84 plus 0.75. Let's go back to quadrant and see if I got that right. Yeah, looks right. Let's just double check. It's an I on that, and I on that, 0.75, okay. So now that will be gripped nice and firmly. We're looking good, looking very good. Okay, we need some more tubes. Let's go back to the front plate, or the back plate, and let's show the back plate felt, and let's now make tubes. No, E, there, and there, and they need to go all the way to that front plate as a joint. Okay, so they're the right length. And we need some more tubes. Let's go back to the front plate and let's look at the felt sketch we did, which is that one. And let's project these tubes and these tubes. Okay, finish that sketch. Let's reveal that sketch. Now let's extrude from the front plate. Those tubes need to go and touch the friction plate. Distance object, friction plate, join. Right, let's hide some sketches. Let's go back to the quadrant. I think we're good. Let's hide some more sketches. That's not bad. It's not bad. Okay. Now we need to think about wires. And we need to think about mounting. Now you kind of want the wires discrete and not getting in the way. So I kind of like using tubes because we're going to have the wires come out the back probably. You've got a kind of choice. You can have the wires come out the back and then go into a box, which is what I did with the Spitfire. That's nice because you can pull all the wires together. You can do all the jointing inside the box, and you can also shape the box to give it a camber or an angle of like 10 degrees, which often was the case. And it was a tidy way of sort of holding all the wires. I'm going to do a kind of quick and dirty on this though, and let you do that. So the first thing I need to do is put a mount on. So let's go and get the hub. Let's put a short VESA extension on. Okay, that's good. Where is it? It's here. Let's get it in the right sort of place. Rotate it around. 180. Good. And just out of the way for now. That's good. Okay. And let's make a joint between that, the center of that, and the center of that. Now we don't want the center. That looks like it'll get in the way of the screws back here, although that might not be a big problem. But actually what I'm going to do is I want more space at the bottom because I want to, I'm rotating things. Let's put that back to 0 because I want to just poke an RJ45 right through the back. So that's my kind of quick way of doing it. So that's how it's going to mount. Let us do some screw holes. Let's hide the. Let's go to the VESA. Let's hide the wedge. There we go. Let's make. Now this is the back plate, so we should be on the back plate as we do this. Back to the back plate, and right-click, create a new sketch. I feel like a new sketch is a little safer. Let's project the position of the holes. There, 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 and there. Do. Let's sketch 5. Let's hide the VESA, the extension arm. Let's E. Let's get these holes punched in. Oh, there. Let's take them. Let's take them 4 mil, I guess. We've got 5, haven't we? Let's take them 4. And I just need to check actually, let's put this back, because we're going to, what length of screw we're going to use. Go from here through to the back of the hole, which is 8 mils will be fine. And okay, let's just hide the extension on. Let's chamfer. No, we're not chamfering anything, but we need to remember some threads. Let's select that. No, this is how you do it. You have to select that, 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 and then hit the thread. So now I've got an M4 thread, so that will hold. That's how we'll fasten that on. Yeah, pretty sure that's right. Let me just check. Yeah, it's chamfered here and it screws in. And let's hide that sketch. So that mounting is there. So now we just need to do the RJ45. Okay, it's time for a quick and dirty wiring up. So we need another little plug-in thingy. I think it's a plug-in component. Or is it a manufactured part? What did I call it? Oh, it's my RJ45 cutout template. So let me do that. In fact, I'll drag that into the back mixture, back panel, because that's where it's going to go. Yeah, this wouldn't be good enough in reality, but it'll do for now. So let's just put it somewhere. I think there's space for it here. There's a certain amount of space, doesn't it? And what way around will the levers go? I think we will. So that's the lever, so the wires. Yeah, let's go for that. And let's just pop it through here. Okay. Yeah, that'll do. Right. Combine. Back panel. Select. Cut. Done. Okay. Now we will remove. Is it gone? RJ45. So there's our cutout. Now, you cannot fit an RJ45 into a 5mm thick plate. You need it to be 1.8mm. That's what I've found to be the right amount. So let's make a new sketch on that panel. And let's project. Quick and dirty will project everything. And then I will make again, a quick and dirty really would be to just do an outline on that whole thing. There we go, and do it. So do -1. There we go. I think you need -2 or -3 to be clear of everything. So we'll do -3. Okay, and now I can hit E. Oh, where's the sketch gone? Now I can hit E. Let's try again. E. Oh, I've lost the sketch. E and yes, there's a little piece missing there. Oh, the sketch isn't even finished. Let's finish the sketch. Good. Now let's show the sketch. E. There we go. Take that all the way to the object, which is here, with an offset of 1.8. Yeah, 1.8, good. So now it'll drop into there. It should print right, shouldn't it? Yeah, it'll drop into there and clip in, nice and neat. One more thing we need to do, let's do it on that same sketch we just did, is that we always, with the wiring, we always merge the positives. So let me just put a little, and we do that by putting a 3mm flange screw to a mounting post that we kind of bind the red wires together with. So we need to just find a place for that. So let's just put that somewhere. Here will do. So let's be deliberate about it. Let's make it here, continuation of x, yeah, and a distance 10. Okay, and let's put our circle. There it is at that point. Good. And the D, we need two circles actually. We need a 3 mil hole. So let's put the D on there. Okay, being a bit hasty here. D on there, 3 mil hole, and then an offset of 2, because the flange screw is 6 mil, and we've only got 5 mil to go down. So what I'm going to do is bring up this little pedestal thing by 1 mil, which gives us 6 mil. So let's finish that sketch. Show that sketch. Okay, E, bring that up by 1 mil. I think we can hide this sketch now because we've got that little piece, and let's bring that down by 4.5. So we should have 4.5, 5.5. That's not enough, is it? It probably is actually, but because there's a thickness to the wire that's going to wrap around it. But just to be safe, let's make it 2 mil. Okay. And then we've got the inside of that, which is a 3 mil thread. So that's going to be our post for binding the RJ45. And actually what we can, no, we'll do that later. So now we've got 3 wires will come from here. One red will go there, and that will go into this RJ45. The other wires, it's not going to be too tidy this, but they will just come straight from here to here. What I like to do, and I guess we could, yeah, we could just do as a demonstration, is if you make another post, another, where would that be good to go? Let's do it on the other side for symmetry. Let's make another line here. Oh, something's gone a bit off here, hasn't it? That isn't symmetrical. Right, I'm not going to worry about that. I'm going to take that out. Distance of 10. And let's just make sure that that connects it there. Okay, so that is symmetrical, even though you've got this funny little offset business going on here. And we're going to make a tube. It's only 3 wires going through it, so 4 mil's probably fine. Yeah, 4 mil's fine. Let's have an offset of 2 mil, why not? And yes, this is another thing we're going to do. We need to be able to get it's going to carry the wires from the other side to this side, but then they've got to kind of come out again. So I'm going to make a line from here to here, a solid line, and a solid line from here to that distance bit, and then another solid line from here to here. And I'm going to E this tube up to this panel here, offset by 3 mil. That will allow us to take the wires out of that upper mag hole, discreetly pull them along, go down the tube, but now we've got to get them out of the tube. So if I hold here, and I select the profile, and then I hit E here, I'll cut away a cavity to get them out of, let's make it 4 mil, because it's a bit more than you need, but I'm going to just do a bit of curving so that this prints reliably. that sort of raised roof thing is not going to print very well in midair. But if I curve that round like that, I think we'll get away with that quite well. That seems to be a good amount. Hide the sketches. I think we're there. So the wires will come from that mag hole in here, down here, pop out there. We merge the reds here, and then all the wires following the conventional wiring for throttle quadrants will come out there. I think I've forgotten one thing, which is that we're going to put panhead screws here, 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 and here. And if I get rid of that back plate, friction plate, I need to thread all those 4mm. Okay. I need to check the lengths because we've only got a certain screw lengths available. What's the length between there and there? 25. Right, so we'd have to be using our 40mm panheads. I'm pretty sure we've got 40mm panheads. And then I clearly have forgotten one more thing, which is the holes coming through the top here. So let's reveal backplate there. Backplate sketch. One here? Yeah, there it is. So let's just select. You keep the mouse held and it lets you select different things. There, that one. And same again. There, right here. E, drag that up. This is to object. Cut. And then if I go to the front plate and hide the front plate itself. No, that's wrong, isn't it? I basically just want to put let me go back to the quadrant. I basically just want to put some threads into these tubes. We haven't got threads in those tubes yet. Let me hide some sketches. It's a bit messy now. Let's hide those sketches. Let's hide the whole front plate. There we go. Now select that, and put a 4mm thread in that. Done. Have I done that? Yeah, that's done. And put the front plate back on. That's it. That's a quadrant. Okay, for the next video, I'll show you how to do bent levers. And the other thing you can have a try anyway with is if we are going to have a third prop, a third lever. On the Spitfire, it was kind of easy enough. It went externally here. One thing to be aware of, the closer you put these two mag holes, the more risk you have that the magnet in one interferes with the magnet in the other, so that you get a kind of interference that you turn one lever and it affects the other. So don't get these too close, basically. We've got a separation here of 5.5mm, I think. I don't think you'd really want to go less than that. And actually the prop one isn't so bad because the magnet is a bit further away. But that's something to be careful of. Now, if the whole thing is contained in a single unit, you're going to have to put another plate inside the unit. And because that plate's going to have to mount another mag hole. So you'll just have to work out the best way of doing that. I mean, you could just mount a third plate on top of that and have the whole thing be kind of a 3-layer sandwich. You don't really need that whole plate to go the whole distance. If it was just chopped off halfway along, that would be fine because it's only at the bottom that you really need to be able to mount the mag hole. So that's the other thing is the plates to mount mag holes internally, and I'd go 4mm as a plate thickness for that. I think that's it.